Welcome to the Day 9 video. Today we will be simplifying square roots and then using the square root method. The first objective is a review of what you've learned the past 2 years, so in algebra and geometry. That will be simplifying square roots and then operations with square roots. So multiplying roots, dividing roots, adding, subtracting roots, and then the square root method is new. We are going to start by reviewing simplifying square roots. So we're going to start with simplifying the square root of 48. There's two different methods, so I'm going to show you both. Both work, you just pick the method that you prefer. The first one is to look for pairs of numbers. So for this method, what you do is you take your square root and then you break it down into factors. So 48 is 4 times 12, and you keep breaking down until you can no longer go further. So 4 will be 2 times 2. I can't break down 2 anymore. 12 will be 4 times 3. This 4 is 2 times 2, and now I can't go any further. Now what I'm looking for is pairs of numbers. So I have a pair of 2's, I have this pair of 2's, and I have that 3 left over. Any number that has been broken down, you don't need to look at anymore. So I broke down 4, I broke down 12, I broke down that 4, so I don't need to look at them anymore. Any number that's in a pair comes outside the root. So from this pair of 2's, 1, 2 comes outside the root. Not both, just one of them. From that pair, 1, 2 comes outside the root. Again, just one, not both of them. The 3 that's left over stays under the root. Now, 2 times 2 will give us 4, root 3. So that's the first method. Second method is to look for perfect squares. So your perfect squares are going to be 4, 9, 16, 25, 36, etc. So if I look at the square root of 48, the largest perfect square that 48 is divisible by is 16. So I have the square root of 16 times the square root of 3 will give me 48. The square root of 16 is 4, and then I can't break down root 3. So this gives us 4 root 3. You're going to notice with either method you still end up with the same answer. Now method 2 you can notice is faster if you know your perfect squares really well. So for a lot of people it's difficult to see that 16 goes into 48. If you're not really good with your perfect squares, then method 1 is better. I personally prefer method 1 because it never fails. So you don't have to know the perfect squares as well. But either method will work. So now we're going to move on to a few more examples. If we look at the square root of 40, I'm going to use method 1, so I'm going to look for pairs. So 40 is 4 times 10. This 4 is 2 times 2. That 10 is 2 times 5. I can't go any further, so now I look for pairs. I have that pair of 2's, I have the 2 and the 5 left over. Out of the pair of 2's, 1, 2 comes outside the root. The 2 and the 5 stay under the root because they don't have a partner. So this becomes 2 root 10. That's method 1. If you wanted to use method 2 instead, you would look for the perfect square that goes into 40, the largest perfect square. In this case, the largest perfect square is 4. The square root of 4 is 2, and then I keep the root 10. So again, faster if you can see that 40 is divisible by 4. What I would like you to do right now is pause the video and simplify the square root of 72 on your own. Okay, let's see how we did. I'm going to do it both ways, method 1 and method 2. Starting with method 1, 72 is 9 times 8, 9 is 3 times 3, 8 is 4 times 2, 4 is 2 times 2. Now I have a pair of 3's, I have a pair of 2's, and I have that 2 left over. The 9, the 8, and the 4 we broke down, so we don't need to look at those. Out of the pair of 3's, 1, 3 comes outside of the root. Out of the pair of 2's, 1, 2 comes outside of the root, and then we have a 2 that's left over. This simplifies to 6 root 2. Now, if we do method 2 instead, you have to look for the largest perfect square. A lot of you probably saw that 72 was 9 times 8. But 9 is not the largest perfect square that goes into 72. The largest perfect square is 36. 72 is 36 times 2. Square root of 36 is 6, and then I keep the root 2. Okay, if we look at the next example, 6 root 20. To do this example, you simplify the root 20 and ignore the 6 to begin with. So if I look for pairs, 20 is 4 times 5, 4 is 2 times 2. I have a pair of 2's, and I have 5 left over. 1, 2 comes outside, and then the 5 stays under the root because it doesn't have a partner. Now you bring down that 6. So 6 times 2 will give us 12, and then root 5. So I would like you to pause the video and simplify 3 root 50. Good luck. Okay, let's see how we did. The first thing that you should have done is simplified that root 50, which ends up being 5 root 2. When you multiply by 3, you get 15 root 2. You should have more work shown than this. If you have a question, please ask your teacher tomorrow. Now that we've simplified roots, we're now going to do operations with them. So please flip the page. Okay, so the first 3 examples are multiplying roots. So if we look at the first example, 2 root 10 times 3 root 20. What you're going to do is you're going to multiply the numbers outside the root and the numbers under the root. So 2 times 3 will give us 6. Root 10 times root 20 is root 200. Now what you have to do is simplify that root 200. So I know 200 is 2 times 100. 100 is 10 times 10. And I can stop right there. I can keep breaking down the 10s, but they're already a pair. So 10 comes outside the root because it has a partner. This 2, which does not have a partner, stays under the root. And then I have to bring down the 6. 6 times 10 will give us 600 root 2. Okay, with the second example, again I'm going to multiply the numbers outside the root and the numbers under the root. But I end up with a little bit of a difficulty here. I don't know about you, but I don't personally know what root 12 times root 21 is. So I can't multiply 12 and 21 in my head. It's going to be too big of a number to break down. So we could do that. Like in the previous example, we multiplied 10 and 20, and we got root 200, and then we simplified. So that's an option here, multiplying 12 and 21. But because that number is too large, I'm going to simplify the roots to begin with. So if I have root 12, I know that 12 is 4 times 3, and 4 is 2 times 2, so I end up with 2 root 3. So this is really negative 2 times 2 root 3, which is negative 4 root 3. Then if I try to simplify root 21, I get 7 times 3. So there's no pairs. So that 4 root 21, I can't simplify that at all. Okay, so now I've simplified this a little bit. I know that negative 4 times 4 will give me negative 16, and then I have to multiply 3 and 21, which is a lot easier than 12 and 21. Multiplying 3 and 21 will give me the square root of 63. Now this I can break down. 63 is 9 times 7. 9 is 3 times 3, so I have a pair of 3's. The 3 comes out. The 7 that doesn't have a partner stays under the root. And then I can't forget about that negative 16. Negative 16 times 3 is negative 48, and I keep the root 7. So you have 2 options. This option on the left, we multiplied, and then we simplified. This option on the right, what we did is we simplified, then we multiplied, then we simplified again. The option on the right, it looks like it's more steps, because it is, but it's easier to do this second method when you have larger numbers. So when you have larger numbers like 12 and 21 and it's going to be hard to multiply them, sometimes it's a better idea to simplify first. So for the stop sign problem, you have 18 times 6. If you can multiply that without a calculator, then you can multiply and start simplifying. I personally would prefer to simplify first. So pause the video right now and try this problem on your own. Okay, let's see how we did. Now I said 18 times 6 is hard to multiply, so I would suggest simplifying first. So hopefully you started by simplifying the square root of 18. 18 is 9 times 2, 9 is 3 times 3, so I have a pair of 3's and a 2 left over. So that should have become 3 root 2. That root 6 doesn't simplify. So now, this is easier. I know 3 times 3 is 9, and I know 2 times 6 is 12. So 2 and 6 are much easier to multiply than the original problem with 18 and 6. Now, we're not done yet. We actually have to simplify that root 12. So I know that 12 is 4 times 3, and 4 is 2 times 2. So I have a pair of 2's. 2 comes outside the root. That 3 that doesn't have a partner stays under the root. And then I can't forget about the 9. 9 times 2 is 18, and then I keep the root 3. So hopefully that one went well for you. If not, if you made a mistake, hopefully you now see what you did wrong. So that was multiplying roots. The next thing that we're going to do is we're going to divide square roots, and it's something called rationalizing the denominator. Now you may or may not have seen this last year. Looking at this first example, 6 divided by root 3. What I mean by rationalizing the denominator is, in math, we agree that we will never put a root in the denominator. You will never put a square root in the denominator. It's okay if it's in the numerator of a fraction, but it's not okay if it's in the denominator. So in this case, I have root 3 in the denominator, and that's an issue. The way to get rid of that is to multiply by the same root. So what I'm going to do is I'm going to multiply the denominator by root 3 and the numerator by root 3. So my numerator becomes 6 root 3. In the denominator, I have root 3 times root 3, which is root 9. And then hopefully you know that the square root of 9 is 3. Okay, so now I have a root 3 in the numerator, the top of the fraction, that's okay. But I no longer have a root in the denominator. The last thing that we have to do is simplify. So 6 divided by 3 is 2, and then you keep the root 3. You do not simplify those two, and that's because one is a root and one is not. So you wouldn't do 3 divided by 3, only like terms. So now let's look at the example to the right, the square root of 9 over 24. First thing that I'm going to do is simplify this. So I'm going to break that root up so it's root 9 over root 24. The square root of 9 is 3. And then I'm going to try to simplify that square root of 24. So I'm going to do that over to the left side. So 24 is 4 times 6, 4 is 2 times 2, and 6 is 2 times 3. So I have that pair of 2's, so 1 comes outside the root. This 2 and this 3 don't have partners, so they stay under the root. So this becomes 2 root 6. So really I have 3 over 2 root 6. Now that root 6 that's in the denominator, that's an issue. We've agreed in math that we're not going to put a root in the denominator. So what you do is you multiply by the same root. So multiply by root 6 and multiply by root 6. In the numerator, that leaves me 3 root 6. In the denominator, I have 2 times the square root of 36. Now, hopefully you know that the square root of 36 is 6. And when you multiply that by 2, I get 12. The last step is I need to simplify those two numbers. 3 divided by 12 is 1/4. So this is root 6 over 4. Okay, so now you have one to try. We got to a stop sign problem, so I would like you to pause the video and try this one on your own. Start like we did the previous problem by simplifying the numerator and the denominator. Good luck. Okay, so that root 27 you should have simplified to be 3 root 3, and then the root 44 simplifies to be 2 root 11. Now that root 3 in the denominator, that's not an issue. It's the root 11, the root 3 in the numerator is not an issue. The root 11 in the denominator is where we have the issue. So you're going to multiply by that same root, root 11. The numerator, you get 3 root 33. In the denominator, root 11 times root 11 is 11. Multiplied by 2 is 22. 3 and 22 don't simplify. So your answer should have been 3 root 33 over 2. If you have any questions, please ask your teacher in class tomorrow, and he or she will go over that question. So this was all review so far. You've simplified square roots before, you've multiplied them before. Rationalizing the denominator is new for you. But the reason we're doing all of this is so that we can solve equations using the square root method. So that's the last page. Please flip the page so we can talk about the square root method. Okay, so the square root method is another solving method. So far, the solving method, the only one that you've learned, is solving by factoring, and I guess solving by graphing. So we've solved by graphing, we've solved by factoring. In previous classes, you've talked about the quadratic formula. So another method that we also have is the square root method. What's really important is when to use this method. It's a really nice method. You can use it when you have a squared term, so like an x squared, but no term to the first power. So, for example, if you have something like x squared plus 2x plus 7 equals 0, you have an x squared, but you also have x to the first. So in this case, you would not use the square root method. In an example like x squared plus 7 equals 0, I have x squared, but I have no x to the first. So here I could use the square root method. So we're going to do some examples. Here are your steps. The first thing is you want to isolate the squared term. So if we look at this example to the right over here, I'm going to be using the square root method because I have a squared term, and then I don't have another term with an x. So my first step is to get that squared part alone. So I'm going to subtract 10. So I get 2 times the times x minus 1 squared equals 64. Dividing by 2, I get x minus 1 squared equals 32. On the left side, don't FOIL that out. It's very tempting to take that x minus 1 and actually square it. That makes your problem so much harder. Don't do that. So that was step 1. Step 2 is to take the square root of both sides. On the left side, the square root and the square cancel, so I just have x minus 1. On the right side, I actually have to simplify the square root of 32. So 32 is 2 times 16. 16 is 4 times 4. I have 2 times 2 and another 2 times 2. So here I have a pair of 2's, another pair of 2's, and a 2 left over. I have a 2 from each pair that come outside the root, so that's 4, and my leftover 2 goes under the root. So the square root of 32 is 4 root 2. Now what you have to remember is because you are taking the square root here, you get 2 answers, a positive and a negative answer. So that's step 3. Don't forget the positive and the negative. Last thing, we have to solve for x. So we're going to add 1 and add 1, and I get x equals 1 plus or minus 4 root 2. Now, I can't actually combine those terms because 1 doesn't have the root 2, but the 4 does, so they're not like terms. So you just leave your answer like that. And this is 2 answers, 1 plus 4 root 2 and 1 minus 4 root 2. Okay, so let's do another example. Example number 3. You're going to use the square root method here because I have an x squared and then I have no other term with an x. So I need to get that squared part alone. I'm going to add 5, add 5. Okay, and when I do that, I get 4x squared equals 64 again. So I divide by 4, and I get x squared equals 16. Okay, so I isolated my variable. Now I take the square root. So the square root and the squared cancel, and I get x equals. On the right side, the square root of 16 is 4. Now don't forget step 3, which is the plus or minus. And then we need to solve for the variable, which we've already done. X is alone, so my 2 answers are x equals positive 4 and x equals negative 4. So, I think we're ready for you to try one on your own. Please try example number 14. Good luck. Okay, let's see how we did. First thing that you should have done is solved for that squared part. So we get y plus 3 squared equals 52. Then you take the square root, so I get y plus 3 equals, if you simplify the square root of 52, you should have gotten 2 root 13. And then don't forget the plus or minus. Last thing, subtract that 3, so I get y equals negative 3 plus or minus 2 root 13. Now you can't combine those like terms, or because they're not like terms, you cannot combine them. We have negative 3, which doesn't have a root, and you have 2 root 13, which does. So do not combine the two. So hopefully that went well. I have one more example that I would like you to try, which is example number 15. So please pause the video and try this one on your own. Okay, let's see how we did. You should have gotten down to m minus 4 squared equals 9. When you take the square root, you get m minus 4 equals plus or minus 3. Solving, you get m equals 4 plus or minus 3. Okay, those are like terms, so you actually need to combine those. 4 plus 3 is 7, 4 minus 3 is 1. So those are the two answers that you should have gotten. If you didn't, please make sure that you go back and rework the problem. If you have any questions, please bring them to class tomorrow.